Here's a video to help with tangents to circles. So we know a tangent line intersects a circle at exactly one point. So here we have a line and it is tangent to the circle, which means it touches in exactly one point. So what I want you to know is that anytime you have a tangent line and you extend the radius to the tangent line, a 90-degree angle is formed. Okay, so that's going to be our main property in this lesson. Tangent to a radius equals 90. So just to demonstrate, if I have a circle and I have a tangent line that connects to the radius, there is going to be a 90-degree angle. So any tangent to any radius in that circle is going to form a 90-degree angle. All right, number 3 is going to be one of our example problems. We always skip around on examples, allow you time to do some examples. So what I notice here is that I have a tangent line that is connected to a radius, so I have a 90-degree angle. I have a 90-degree angle which forms a right triangle, and I can see that one of the legs is 7 and the other leg is 19. So using Pythagorean's theorem, I have the legs, which are 7 and 19, squared is equal to the hypotenuse squared. I need you to know that the hypotenuse is always across from the right angles, and it's always the longest side. So with this in mind, when we simplify, this is what we get. 49 plus 361 is equal to x squared. We take the square root of each side, and we find out that x is equal to, let's round to the nearest tenth, 20.2. You try number 4 and then push the play button when you're ready to see if your answer is correct and the work is correct. Did you get x is equal to 14.2? All right, so if you did not, here we go. A squared plus b squared equals c squared. And of course, a and b are the legs, so here and here. And so we have 11 squared plus x squared equals, well, wait a minute. If you notice, the outside is given and it's 7. However, we have to problem solve and figure out the radius is the same in any circle. It's 11. So my C is going to be 11 plus 7, which is 18. Okay, so simplifying, we get x is equal to 14.2. All right, take a look at number 7. The first thing you want to do is if you see a radius to a tangent, go ahead and put your box in there for your 90-degree angle. So when you get ready to set it up, Pythagorean's theorem, a squared plus b squared equals c squared. It's easy for you to see what's a, what's b, and what's c. You can see that the hypotenuse is x, so we make it x squared. The legs are 6.4 squared. And wait a minute, how much is this leg right here? It's 3.5 here, so the diameter is 3.5 plus 3.5, so we get 7. All righty, we square everything and we get an x is equal to 9.5. For number 8, you try it, and then when you're ready, hit play and see if your answer is correct. If it's correct, go to the next one, and if it's not correct, go through the steps with me. All right, so here we go. If you're wondering why I have 2 x here, is because the radius is x, and then the other side is x, so that's x plus x, which is 2x. Okay, here is more about tangent properties. Of course, now we have not just one segment that's tangent, but 2, and they're coming from one point. So anytime you have tangents from one point, the segments are going to be congruent. Okay? So take a look. It says if a polygon is circumscribed around a circle, then all sides are tangent. So that means that DA is the same as FA, DB is the same as BE, and EC is the same as FC because they're all tangent. So we're going to be able to take those properties and solve problems using those 2 properties. Here goes. Every time you see a radius connected to a tangent, go ahead and put in your right angle. And so now you can clearly see that we have a right triangle and we have the legs. However, that's not going to help us find SV, which is what? The hypotenuse. But what we notice is that the side, the tangent to the circle from point S, and the tangent to the circle from point S that goes to U, they are congruent. So I'm going to write 10x minus 41 is equal to 4x plus 7. I'm going to solve that and solve for x, and then I'll have both sides to my triangle. Now that I know that x is equal to 8, I'm going to take that and I'm going to plug it back in. So it's going to be 4 times 8 plus 7 and see what we get. So I get the side is 39. So now let me pull out my triangle here. I have that this leg is 39 and this leg is 17. So then I can use Pythagorean's theorem. Use Pythagorean's theorem and see what you get for SV. Alrighty, so here's the math. We find out that C is equal to 42.5. So what does that mean? It said to find SV. So SV is equal to 42.5. Alrighty, let's do this last one. It says find the perimeter of the quadrilateral. Well, what we know is we know that the sides are going to be congruent if they're tangent. So if this right here is 23, then this little piece in here is also 23. Well, what I'm going to do is I'm going to subtract 23 from 37.5 and find out what the other side is. Here goes. All right, so I find out that these tangent segments are each 14.5. And if this one right here is 27.1, then this one right here is also 27.1. So what I'm going to do is I'm going to take 52.5 and I'm going to subtract 27.1. And I get 25.4. So this little piece in here is 25.4, and the tangent right next to it is also 25.4. So now we can add them all up together and see what we get. And when we do that, we get the perimeter is equal to 180 units. Well, that concludes the tangent properties and problem solving. You have any questions? Please see me for AEP Pass. Thank you.